Let's take a look at this equation, z to the fourth equals 1. What we're going to do here is find the fourth roots of 1, which in math parlance is the fourth roots of unity. If we had z to the eighth equals 1, we'd be finding the eighth roots of unity. So this is a special type of problem where we're finding the complex zeros of an equation. And the interesting thing here, what I want you to note on this one, this is just kind of an intro one. So let's take a look first. Notice this. If we plugged in 1, of course, we would get 1. So that tells us that one solution here is 1, right there. We're looking over here on the right at the complex plane, and I've labeled 4 points in the complex plane. And now notice that if we take I and make the fourth power, we could write that as I squared times I squared, which is -1 times -1, which is also 1. So that checks. So that tells us that I is also a solution to this equation right here. And you probably guessed properly that by putting -1, we get 1. So -1 is also a solution. And finally, if we plug in -I, raise it to the fourth, the negative raised to the fourth is just going to turn into a +1. So this all reduces to I to the fourth, which is again 1. So the 4 numbers that I have listed here are all solutions to this equation. And what I want you to notice is that they're equally spaced on a circle of radius 1. And this is a common pattern when you're solving powers of a complex number equal to a constant. You'll always end up with the exponent representing the number of solutions, and they will always be equally spaced on a circle. Really, really nice geometry. Now, I kind of just told you what the answers were to this one. Let's go through and do one of the, well, let's do this one by a math approach. So we just kind of looked geometrically here and I showed you what the answers were. So now if we do this mathematically, if we're going to solve the fourth unity, we would write z to the equals 1. And the first step is to rewrite the right-hand side in trigonometric form. And so we need 2 things when we write a number in trigonometric form. We need its distance from the origin, and the distance to the origin for this complex number 1 is 1. So we'll put a 1, and then CIS, that stands for cosine of theta plus I sine of theta. We have to choose what the theta is. And the theta in this case, theta is always the angle rotated from the positive x-axis. That, of course, is 0 in this case, so 0 degrees. And now there are 4 solutions. We will always have whatever this exponent is, that's going to tell us how many solutions we have. So what I want to do here is just note that there are going to be 4 solutions, and they're always going to be evenly spaced. So if we have 4 solutions, we know that they're going to be 90 degrees apart. And I got that by taking 360 and dividing by 4. So if it was z to the 6 equals 1, we'd have 6 solutions 60 degrees apart. So pretty nice geometry there. That's a simple thing to do. So now I'm going to write this. I'm going to say, okay, a lot of books are going to label their solutions z0, z1, z3. I like to start at 1 and go to 4. I like to count them 1, 2, 3, 4. And the first solution is found by taking the fourth root of each side. And so when you find your first solution, I'm just going to write the right-hand side here at CIS 0 degrees. I don't need 1 in front, obviously. So I'm going to use kind of a modified de Moivre's theorem. De Moivre's theorem tells us how to apply a power to a complex number in trigonometric form. And what it says is that you put the 1/4 as an exponent on the 1, and of course 1 to the 1/4 is just 1, so that doesn't really matter. And you are going to multiply this exponent by this angle. So what we end up with is 0 degrees times 1/4, well, that's just 0. So we end up with CIS 0 degrees. So that is the first complex number that satisfies the equation. And if we wrote this back in standard form, it would be 1 plus 0i. Of course, you don't need the 0i. You could write that as just 1. Now, once we've got one solution, it's really nice because we bootstrap our way around. We just said that the answers are 90 degrees apart. So we have our first answer right there. Now our second answer will be found by adding 90 degrees. And if we want to convert back to standard form, this is cosine of 90 degrees, which is 0, plus I sine of 90 degrees. Sine of 90 degrees is 1, so we get 0 plus I. And if you wanted to, you could write that as just I, in the same way you can write this as just 1. And down here, Z3, same idea. We'll just add another 90 degrees. Cosine of 180 is -1. Sine of 180 is 0. So we end up with that, which we could simply write as -1. Z4, final answer, we add 90 to that. CIS 270 degrees. Cosine 270 is 0. Sine of 270 is -1. So we end up with 0 minus I, which we could reduce to just minus I. So those are the answers. These are the fourth roots of unity. These are the 4 complex numbers that have a fourth power equal to 1.